So, hello everyone. I hope you all had a good weekend. Um, Today we're going to go over the cosine law, um, which is review of grade 10, so we should be able to go through it relatively quickly. I would like to go over the proof of the cosine law, and I'm also going to discuss how the ambiguous case of the sine law could potentially come in and affect the cosine law. So, what is the cosine law? When you have a non-right angle triangle that doesn't have the sine law key, you have to use the cosine law. Now there are two cases of that. We're going to start with the first case. So here's an example of the first case. In triangle ABC here, I've given you angle A, I've given you side little c, and I've given you side little b. Now, you can clearly see that there is no sine law key, because if I go across from the given angle, that side is actually unknown. In fact, that's the side that we'd be searching for. So we have three pieces of information given, an angle and two sides, and we do not have the sine law key. It is not a right angle triangle, therefore we have to use the cosine law. Some students think of this, or some teachers teach it as well, as being the angle is contained between two given sides, but I like to use the idea of the no sine law key. Okay? So we want to set up the equation for the cosine law, which is actually, it can be a fairly intimidating equation when you first look at it. You did see it in grade 10, so hopefully this isn't too intimidating anymore. But what's nice about the cosine law when you're looking for side length is we just said that the side length we're searching for is little a. Well, little a is actually already almost isolated on this side of the equation. So all we have to do is plug in all the numbers where they're supposed to go and use our calculators to find the final answer. So the cosine law is a squared is equal to b squared plus c squared minus 2bc cosine a. We know little b, we know little c, and we know big A. So we can just type all those numbers right into the equation. Use our calculator, and then square root at the very end to be able to get our final answer. So it's actually quite an easy equation to use, even though it's intimidating, at least for case A. Okay? When you're looking for a side length. So let's move to the proof of the cosine law. Now I just took this proof directly out of your textbook. So you can go to page 286 if you want to and see it there, but I wanted it to be in the note that I'm going to post on the Google Classroom as well. So you're going to notice that we have another triangle ABC very similar to our sine law proof. And in fact, we even draw a dotted line down the height of the triangle, exactly like we did the sine law proof as well. The main difference here is we're going to be using the cosine of the angles A, B, and C. Okay, so we're going to be doing the cosine of angle C in this right angle triangle, and then we're going to be using the cosine of angle B in this right angle triangle. And because we're doing the cosines, we need the adjacent sides labeled for those two triangles. Because we don't know the length, we're going to call this length DC x, and because the entire length is a, we're going to call the length BD a minus x. So the first thing we're going to do, in triangle ADC, which is this small right angle triangle here, we're going to write cosine C is equal to x, the adjacent side, over h, the height of the triangle. Okay? Sorry, my mistake. X over b. The h messed me up with hypotenuse there. Sorry about that. So it's x over the hypotenuse. The hypotenuse is b in this case. Okay? So cosine C is equal to x over b, which is going to allow us to isolate x equals b cosine C. We're also going to write the Pythagorean theorem for that triangle. So the hypotenuse squared is equal to h squared over plus x squared. All right? Then we're going to move over to triangle ABD. So the bigger right angle triangle, we're going to set up the Pythagorean theorem. C squared is equal to h squared plus a minus x squared. We're going to expand the trinomial. A minus x squared becomes a squared minus 2ax plus x squared. And we're going to rewrite it in this format. We're going to join the h squared and the x squared in the middle here. We're going to put the a squared at the beginning, and we're going to put the 2ax at the end. Now, this proof is not very intuitive. I would not expect students to be able to reproduce this proof without further studying it in detail, which I usually don't do. It's not as nice as the sine law proof to some extent, because it's just not as intuitive, all right? But it does still work. So let's see what we're going to do next. Well, h squared plus x squared is right here. So we can replace h squared plus x squared with b squared, and x is equal to b cosine c, which we're going to replace right there. Okay, so b squared is going to come in and replace that, and b cosine c is going to replace that, and now we have the cosine law. So that is the proof that the cosine law works in an acute angle triangle. There's also the proof of how the cosine law works in an obtuse angle triangle. Now, I'm not going to spend a lot of time on this. The only thing that's different, it's going to look almost exactly the same as the previous proof, except that we're going to use 180 minus c, because it's 180 degrees minus c to get the obtuse angle inside this triangle here. Okay? Sorry, my mistake. 180 minus c, this is c. So we're actually finding the value of this acute angle here inside this right angle triangle here. Okay? Now, because we're using 180 minus c, we have to use a substitution here. The cosine of 180 minus an angle is equal to the negative cosine of that angle. And we've already seen that. I didn't exactly state it that way, but let's just show you where that comes from. If I draw my magic circle, we saw with the angles in standard position lesson from the other day that if I mirror image, which is really hard to do here, if I mirror image this point on this side, the cosine is the length of the adjacent side to this right angle triangle. Well, that mirror image over here gives you a negative of what that number was, because it's on the negative side of the x-axis. So it would be 180 minus theta, which would be the angle here. So if you do cosine of 180 minus theta, it's the exact same thing as doing the cosine of the angle, the related acute angle, which is here, but the negative of it, because it's on this side of the x-axis. So I'm not going to get into that too much, because we're actually going to talk about the standard position angles a little bit more in detail later on. But once you do that substitution of 180, cosine of 180 minus c equals negative cosine c, you basically do almost the exact same thing as before to get to the cosine law. So you'll notice here that there's a negative that shows up to be able to make the minus sign show up here. So I'm not going to spend too much time on this one. It's almost the exact same thing as the previous proof, just with that little substitution involved here. Okay. A little bit more important for us, though, is you should be able to write the cosine law for any given defining letters for the triangle. So you've now seen the cosine law written as a squared is equal to something. You've seen it written as c squared is equal to something. I just want to spend a couple of minutes to talk about the fact that you should be able to write the cosine law no matter what the letters are that are defining the triangle. Okay? So let's say I was asking you to write what would be the equation to find little d in this triangle. So using the guide of the previous equations, this is the way I usually think of the cosine law. The cosine law starts by looking kind of like the Pythagorean theorem. Okay, so what are the other two letters involved with d squared? Well, what are the other two letters involved in this triangle? It's little e and little f. So you'd have little e squared plus little f squared. Then there's always a minus 2. And then the next two letters always match these two letters, but they're not squared anymore. So it's times e times f, and then times the cosine because it's the cosine law. Now, which letter goes at the end? Well, that letter has to match the lowercase letter that started it all. So it would give us a capital D. Exactly. And either you can remember that pattern, which I strongly recommend you do if you don't already, or you could probably assume that you're going to be given some of these formulas on equation sheets and stuff. The equation could be given on the formula sheet with any letters in it, but you should be able to rewrite it no matter what the letter is that you're trying to isolate. Okay. I don't know if there's any questions at this point so far. So I'm not seeing any questions in chat, so let's continue. If you have any questions, please just put them in chat and I'll stop and discuss them with you. The next case we're going to look at is what happens if you're looking for an angle. Now what I'd like to do is concentrate on the algebra of isolating the angle in the cosine law. And then we're going to talk about the actual example that's coming up next. So let's say I was giving you a cosine law equation, such as, I don't know, well, let's use the one that we just used up here. So d squared is equal to e squared plus f squared minus 2ef cosine d. If I was asking you to find an angle d, let's say you were given enough information to find angle d, you'd have to isolate cosine d in this equation to get angle d all by itself. Now there's two ways of doing that. I'm going to show you the more advanced way, and I'm not even going to talk about the second way. And here's how it basically works. Because cosine d is trapped inside of this term, the whole term is negative, and we don't like to isolate variables when they have a negative value in front of that term. So what we're going to do is we're going to move that whole term over to this side. And at the same time, because we don't want the d squared anymore on that side, we're going to move the d squared over to this side. So here's what it's going to look like. You're going to have a positive 2ef cosine d, which came from this one moving over to that side, equals the e squared and f squared don't change. And we're going to subtract the d squared that was on that side. Now we have to divide to get rid of the 2ef and get the cosine d all by itself. So cosine d is going to stay there. The e squared plus f squared minus d squared isn't going to change. But we're now going to divide by the 2ef. And one thing I'm going to recommend you do, and textbooks don't show this, this is something you need to know for it to work on your calculators. If you want to type this all in one step, you absolutely have to have brackets around the entire top and the entire bottom, which I've discussed with you before. Anytime you have a bunch of stuff in the numerator, adding, subtracting, a bunch of stuff in the denominator, adding, subtracting, multiplying, dividing, whatever it may be, you really, really should put brackets around the entire top and around the entire bottom. And that way you can actually type all of that into your calculator in one step. Now we're not done. We're trying to get d by itself. So what do I do to destroy the cosine? That is correct. To destroy cosine, you have to arc cosine both sides, okay, to isolate d. Now, I wanted to discuss that because what kind of number should you be expecting as your answer when you do this whole division here? Because you have to arc cosine, it should be a number between 0 and 1. With a caveat, which I'm going to discuss with the next example. Okay? So let's move over to the numerical example of this. Now, I've got your numerical example down here, but I want to discuss the fact that we are going to have to beware of the ambiguous case, and that's going to come up in a minute. All right, so you just keep that in mind. Okay, so somebody in chat's figured out what I was alluding to a couple of seconds ago, what my caveat was. So you're going to see that happen in this one. All right, I don't want to give away the surprise though, so you'll see what's going to happen. So when you have to worry about the ambiguous case, besides the fact if you're using a sine law to find angles, is in this case here. So I'm asking you to solve this triangle, okay? Well, to solve the triangle, we're usually going to want to pick an angle to start with, and okay, let me slow down a second here. First of all, why do I have to use the cosine law for this question? Well, there is no angle given, therefore there is no sine law key. Okay, there's no sine law key if there's no angle given. You need an angle and an opposite side given to use the sine law. All right, so you can't use the sine law for this one to start at all. It's not a right angle triangle, so I have to use the cosine law. But I'm going to be using the cosine law to find an angle. Now let me discuss what the problem is here. It says which angle is the safest one to start with, knowing that we usually use the sine law to find the second angle. So what do I mean by that? Well, let's pretend for a second that we find angle Z as our first angle, okay? Let's say angle Z is 39 degrees. I'm just making that number up, all right? Now I have a sine law key. So now I could use the sine law. But here's the problem. That 9.6, which is your key length, is shorter than both of the other two lengths that we'd be using in the sine law. And we discussed that the ambiguous case is what happens when you're looking for an angle and your key side is shorter than the other side that you're working with. Well, the key side is shorter than both of those sides. So no matter which angle I'd be finding next, I'd have an ambiguous case for both of those scenarios. And we're trying to avoid the ambiguous case. Now, one way we could completely avoid it is by using the cosine law again to find our other missing angle, okay? But what's funny is in textbooks throughout my education, they always recommend using the sine law to find the second angle, which we're going to do that in a minute, because it's faster, okay? So what I want to ask you, based on what I just discussed with you, what angle should we start with? We can't start with Z, so it's either X or Y. Which angle should we start with? Now, can you also tell me why we should start with angle Y? I'll give you a second in chat to formulate that. That's correct. If we start by finding angle Y, the opposite side to angle Y is the longest side of the triangle. Very good, chat. The opposite side is the longest side of the triangle. That means both of the other two sides are shorter than that side. And when your key side is the longest side, you don't have to worry about the ambiguous case at all. So if you're given the choice, you should always try to find the biggest angle, which is always across from the largest side, in a cosine law scenario where you're looking for angles. Then you can freely use the sine law and not have to worry about the ambiguous case. Or you could just use the cosine law for the two angles. Now the third angle is going to be easy because we're just going to use the 180 rule, right? But like I said, in textbooks, most of the time they do recommend you using the sine law as the second step to this. So let's set it up. We're going to find angle Y first. I actually want to do the entire solution of this one with you. Now, what I would like you to do right now is a little bit of a mental exercise. And I don't want you typing it out in chat. It's going to be too hard to type out anyway. I'd like you to see if you can isolate cosine Y in the cosine law equation mentally. Okay? using what we did on the previous slide. Now I'm going to go back to the previous slide for a second. Okay, let's look at what's going on here. So here was our equation. We took this term, brought it over to this side, took the d squared, brought it over to that side, and then divided by the 2EF. Now I feel like you should be able to do that mentally just by knowing the three letters that we're working with and what we're trying to isolate. So try to think about this. What would be the original equation? The letter that we'd have on this side would be y squared, because we're trying to get cosine y, and the only way to get cosine y at the end of the equation is if we start with y squared, because those two letters always have to match, just one of them's capital and one of them's lowercase. Okay, so there'd be a y squared here. That means what two letters would we have here? Well, if it was a y squared, it would be the other two letters. So it would be x squared plus z squared. And I'm using my cursive z here, so let me draw it a little bit better. So don't get confused about that, okay? And then we always have the minus 2 with all the rest of the stuff, but that moved over to this side, okay? The y squared that was on this side would have moved over as a subtraction over here. All of that would be divided by what? Well, what two letters are in front of the cosine y? The two letters are x and z. There's also the 2 that would become a positive 2, so you end up with 2x and z dividing on this side. So I feel like most of you should be able to, maybe with a little bit of practice, be able to mentally rearrange the equation to get cosine y by itself. Now there are some patterns that some students use to memorize this. If you're isolating capital Y, you're always going to be subtracting by little y squared. The other two letters are going to be their squared adding together. Also, the x and the z here will always match the first two terms here, but they won't be squared. And you just have to remember that there's a 2 in the denominator as well. So there are patterns that you can use to help you write this equation out, but you know, either way, it'll just save you some time if you don't have to write out the original cosine law equation and then isolate. Okay, but if you have to do that, that's fine. It's not that much longer. So let's label our triangle so we know what our side lengths are. So if this is capital Y, across from capital Y is little y, across from capital X is little x, and across from capital Z is little z. Okay, so now we can put all of our numbers in here. So we're going to have cosine y is equal to, so little x, which is 14.7 squared, plus little z, which is 9.6 squared, minus little y, which is 20.6 squared. Oh, try to get that division line to be a little straighter than that. All divided by 2 times, now I don't even have to look anymore because I know it's going to be 14.7, the first term value there, and the 9.6, which is the second term's value there. And let's type this into our calculators. Now I'd actually like you to see me typing this into the calculator. So I'm going to switch over to my calculator. I'm just going to clear out some values here. I hope this works. Okay, so you should be able to see my calculator now. So I'm going to type in bracket 14.7 squared, right there, plus 9.6 squared, minus 20.6 squared, close the bracket, divided by, open the bracket, 2 times 14.7 times 9.6. Close the bracket, press equals. We get a very interesting result here. And I have had students tell me, so let me switch back over to the smartboard here. Oh, I got a negative answer, sir. It must be wrong. Well, it's not wrong. We can arc sine a arc cos a negative answer. And it comes it comes down to our magic circle again. Somebody just mentioned it in chat as well. It has to do with the fact that the cosine is the adjacent side of the right angle triangle in our magic circle. So if I'm getting a negative number for my cosine, that means that my angle has to be greater than 90 degrees. Okay? So it's not just going to be a number between 0 and 1. It could also be a negative number, or in other words, the absolute value of the number has to be between 0 and 1, because it could be a negative value that's, without the negative between 0 and 1, or vice versa. So, and it has to do with the magic circle again. So what's going to happen is we know that if we get a negative decimal before we arc cos, that our angle is going to be an obtuse angle. Okay? And I'm just going to do this. Oops, I forgot the negative in the bracket here. My mistake. So if I arc cos that on my calculator, so I'm just going to arc cos the answer. I didn't round it off technically, like my calculator rounded it off a bit, but I just kept that decimal right in my calculator, and I'm going to second cos that, and that gives me about 114 degrees. Now, it's 114.2, but the distance between 1 degree and 0.2 of a degree is very difficult to see. If you think of a protractor, those two lines are pretty darn close to each other. So I'm just going to round it off to 114. So the reason I'm talking about that, by the way, is because we're not technically done this question yet. We still have to find another angle. So you really shouldn't be rounding off until you're done everything. But because degrees are so tiny, the rounding isn't going to be that big of an issue. So we now know that our angle y is 114 degrees. Okay, well now I have a sine law key. So let's say we find angle x next. Okay, so I'm going to say, this will be step 2 here. We're going to do sine x over little x is equal to my key values, sine big Y over little y. And because my y side is bigger than my x side, I don't have to worry about the ambiguous case. So I'm going to isolate and sub in the numbers as I go. So little x is 14.7 times sine of big Y, which is 114, all divided by little y, which I've forgotten the value of, 20.6. And because my denominator's number, the key side, is bigger than the numerator's length, 14.7, I do not have to worry about an ambiguous case. So I'll just do that off to the side and arc sine it as well. So 14.7 times sine of 114 divided by 20.6. So that's giving me 0.6518 approximately. So I'm going to arc sine 0.6518. Okay. And that gives me 40.6 degrees, which I'm going to round off to 41 degrees approximately. And for my third step, because I'm solving the triangle, I got to find the third angle. I'm just going to use the 180 rule. So 180 minus 41 minus 114 is going to give me my other angle. And that's giving me approximately 25 degrees. And now I've solved the triangle with no worries about the ambiguous case. Okay, so that was angle Z, which I forgot to write. And that's going to be it for today's lesson. Because the cosine law is a review of grade 10, I feel like that should be enough to allow you to do whatever is asked of you in this section. So I'm going to say goodbye for the recording. I'll stay on stream for just a few more minutes.